Hello, and welcome to this OpenTopography video. My name is Chelsea Scott, and in this video, we're going to be looking at several point clouds that have different resolutions and were collected at different times. In this video, we'll be looking at the Solana Beach, which is near San Diego in California. And here's a Google Earth image of where we'll be looking. So here we can see the beach with a volleyball court for fun. And then here is the very steep cliff face. And then above the cliff, we have some apartments and hotels. So in this video, we'll be looking at 3 different data sets. This area has been recorded by many LiDAR datasets, which are available from OpenTopography. And I welcome you to check those out. But here we'll be looking at these 3. So the first is an airborne LiDAR dataset, and it was collected in 2003, and it has just over 1 point per square meter. The second is also an airborne LiDAR dataset, and it is part of the USGS LiDAR point cloud collection, and specifically is the West Coast El Nino dataset. This dataset was collected in 2016 and has almost 8 points per square meter. The third data set is terrestrial or ground-based LiDAR, and it is called the Solana Beach, California Beach Characterization Survey. This data set was collected over a 2-month period in 2017, and it has almost 10,000 points per square meter. All right, so now we're going to use Poetry to look at these 3 data sets. So here is the first data set. So this is the 2003 data set with just over 1 point per square meter. And the points do look relatively sparse, but we can still get information and see some of the structure. For example, we can see the beach, the cliff, and then here is the area above the cliff with the apartments and hotels. And so here we're going to look at that second data set. So this has just or almost 8 points per square meter. And here we do get a much better sense of what the area looks like. So we have the beach here, the steep cliff, and then the area with apartments and hotels. And we can get a better sense of the structure of each of those 3 areas. However, here do note that in the areas that are very steep, so the side of the buildings, and then the steep part of the cliff, we have no LiDAR returns. And this data set does have some attributes. For example, so here we're looking at colored by elevation. But then we can also look at classification. And here the brown are the ground points, and the gray are unclassified. And we can also look at return number. And here yellow points have only 1 return. The red and blue points are multiple returns, where within those, the red are the first returns and the blue are the second returns. And here we also see these very prominent linear patterns within the data sets, and these are an artifact of the scanline geometry. And they do show that the point density varies on a very local scale. And if we were to grid our point cloud at that densest resolution allowed, so essentially 0.5 meter or finer resolution, we would likely expect linear artifacts. So for a data set with these linear scanline patterns, I would highly recommend gridding at a closer to 1 meter resolution. And so then here is our final data set. This is the terrestrial LiDAR data set with almost 10 points per square meter. You can zoom around and we see that we have a lot more returns. And in particular, we have very high definition along the cliff face here that was included in the other data sets. And this data set has color. actually stored as the RGB. And color is not collected as part of LiDAR. So this color would have been collected with a camera and then assigned to the points. But with this color, we can get a sense of the vegetation as well as the stratigraphy within the cliff face. Thanks for watching.